All right, so now we want to look at rectangles. And rectangles are, of course, a very special type of parallelogram. So first of all, we do want to recognize that a rectangle is a parallelogram. So therefore, that means that all the properties of a parallelogram are going to apply. That means that their opposite sides are parallel, their opposite sides are congruent, their opposite angles are also going to be congruent, their consecutive angles are going to be supplementary, and also their diagonals are going to bisect each other. To determine that we have a rectangle, we have two additional properties that we want to pay attention to. And the first one is this, that all four of our angles are right angles. So not only are we, again, if we want to identify all of our properties of a parallelogram, so we can say opposite sides are parallel. We can also say that we know that the opposite sides are congruent. We know that based on being a parallelogram that our opposite angles would also be congruent and all that. But again, remember, all of these angles are 90. So all right angles. Okay. So again, all of our properties, and again, that still applies. Opposite angles are congruent. They're all 90. And we can also say that they're supplementary because 90 plus 90 is 180. So that matches up. All right, what we can also say for our rectangle here is that our diagonals are congruent. Now, we have to remember that our diagonals also bisect each other because, again, based on the definition of a parallelogram, again, that means that we have our parallel sides. We know that they are also congruent. And of course, the primary one is that these are all 90. And based on the diagonals, if we go ahead and identify, we'll identify again that our center here is our X. So I will label this, I guess, A, B, C, and D. So we can just identify. So now the diagonals, this time we can say that the segment AC is going to be congruent to the segment DB. All right, so that is the diagonals are congruent. Now, keeping in mind that because it's a parallelogram, we also have that these diagonals are going to be bisecting each other. All right, so actually, we don't even need those extra little tick marks because they're not only bisecting each other, but they're also congruent. So therefore, they're all going to be the same. All right, so in other words, AX is going to be congruent to XC, which is also congruent to DX, which is also congruent to XB. So we have all are congruent to each other, all the little segments. So again, they're being bisected because that's the part of the parallelogram. And also they're congruent because that is the definition of, again, a rectangle. All right, so let's also now, again, using our coordinate geometry. And so this time what we're going to do is not only check our slope, but we're also going to use distance formula. And we haven't really used the distance formula much up to this point, but you just have to think about it as like a Pythagorean theorem, and it'll be fine. And the distance formula is also on our formula charts, which is nice and helpful. So let's go ahead and graph this out. So we have P is negative 5.3. And there's going to be P. And Q is 1, negative 1. Okay. And R is negative 1, negative 4. And S is negative 7, 0. There we go. All right, let's draw those in. Okay, so for real quick on the slope, let's just go ahead and we'll just identify the slope by just counting it out. All right, so going from S to P, so 1, 2, 3. So we're going up 3 and to the right 2. So our slope of SP slope is going to be, oops, that's 2, not 3. All right, so rise over run. So again, we went up 3 and then to the right 2. And we'll check also here. So again, from R to Q, we are going right 2 and up 3. So our Q slope is also again 3 over 2. And we could do the same thing here for PQ. So we're going up 4 and to the left 6. So PQ has a slope of up 4 and to the left 6, which is going to simplify to a negative 2/3. Can check also SR, and his slope is also, when he goes down, again 4 and then to the right 6, which still simplifies to a negative 2/3. So we have shown that our slopes are all parallel, so we do have a parallelogram. All right, now for the distance formula. So what we want to do actually is we want to not only look at our slopes, but we want to check out our diagonals. Okay, so we want to actually check our diagonals because, again, our property that was special for this particular one was the fact that our diagonals are going to be congruent, which then, of course, we know they also bisect. And if our diagonals are congruent, then we can validate that we must have a rectangle. Okay, so we are going to look at the distance for PR and our distance of SQ. Using the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so that's again the distance formula. It's essentially Pythagorean theorem, so just don't forget that. You could actually form a right triangle on any of these segments and develop, of course, Pythagorean theorem. All right, so our segment PR. All right, so we have the point P is negative 5, 3. R is the point negative 1, negative 4. And we'll just plug that in to our formula. That's right for me. There we go. Minus negative 5. All right. Now, again, keeping in mind that we need to make sure that we follow carefully. You can use a calculator, but watch all of your signs very, very carefully. We have some double negatives going on here. And also, if you're not careful putting this into the calculator, you could possibly make some grave errors. All right, so I am going to walk through this step by step. So again, the negative 1 plus 5 is going to give us a positive 4 squared, plus negative 4 minus 3 is a negative 7 squared. 4 squared is 16. And negative 7 squared is a positive 49. So that's going to give us the square root of 65, which is approximately 8.06. Okay, so that is the length using the distance formula of PR. All right, so like we said, we wanted to check the diagonals. So we're going to do the same procedure for SQ. All right, and so S is -7, 0, Q, 1, -1. All right, and once again, we're using the distance formula, so SQ square root 1 minus -7 squared plus -1 minus 0 squared. All right, so again, a double negative on the 7, so 1 plus 7 is going to give us 8. And -1 plus 0 is, of course, -1. And that's going to give us 64 plus 1, which is the square root of 65, which again is 8.06 approximately. So what we have just done is we have proven that our diagonals PR are congruent to SQ. So therefore, this is a rectangle.